So this is the second part of the closure series. So in this video I'll be covering shorthand parameter names, as well as capturing values with parameters. So in my prior video I covered closure syntax, as well as refactoring and having Swift infer the type for the parameters and the returns for said closures. So just continuing on, I'll be covering shorthand parameter names. So the best example I could come up with is actually using the sort method for arrays. So basically a sort is an array method. It takes in a closure that will tell sort how to, and describe how basically to sort what comes in, whether it's ascending or descending. And it returns a Boolean when the sort occurs between two numbers, and then it will take those sorted numbers and put them into a new array. So that is the output, is a new array. Now, what is sort? Sort is actually a higher order function, and I'll cover higher order functions in a later closure video because it is part of closures. But I thought doing a sort to give you an idea of how to work with shorthand parameter names was the best route to go. Makes more sense too. But there are other higher order functions that also include sort, and they are map, reduce, and filter. So I'll be covering those in a separate video, but I just kind of wanted to give you a little taste of sort. Alright, so how do we go about doing this? Well, I'm going to start from the other side, where we can use, where we actually use a function, a named function. So I'm going to create a list of, or a variable that contains a set of scores. So I'm going to do game scores be an array, because when players begin a game online or whatever, they come in a random order, but at the end of the game or at the end of the match, people like to see who the winners were, who had the higher scores. So just because they come in a certain way doesn't necessarily mean that the way they come in is the way they're going to score, right? So we're going to have just a list of players, and I'm just going to type in some scores here and try to make it as random as I can, without trying to add too much order. Alright, so we have a list, an array of scores, and they're not ordered. Try not to make it too ordered. And then we're going to do some work on this. So the function type for sort is basically a function has to come in, and it has to have two parameters, and it has to output a Boolean. So this is the actual sort, where it actually takes in two numbers and compares them, and if one is greater than the other, then the result is either true or false. So that is here is where we're going to actually build the function for, is to satisfy this requirement right here. So this requirement. Alright, so the long version. The long version is basically using a named function. So I'm going to do sort ascending. Sort ascending? I think so. So actually, we're going to do it's actually sort descending. Sorry, that doesn't sound right. Because we want to do from the highest score to the lowest, not the lowest score to the highest. Because sort automatically does that. If you just do, I'll show you, it automatically does it. So we want the opposite of that. So we're going to do sort descending, and it's going to take in an int two ints, so I'm going to name them so that we can work with them. And it's going to output a boolean. Right, do our brackets, and we're going to do a return I greater than j. Yep. Okay. All right, so we've created a function to satisfy this portion for sort. Right, and then let's give it a whirl. So let's create a new variable, or it's not a variable, it's a constant, new constant, to hold our new sorted list or new sorted array. So we do game score, so bring in the array, do sort, and then parentheses, and we're going to insert our sort descending function we just created. And sure enough, there it is. It sorted all the scores appear from the highest to lowest. All right. So yeah, I mean that's fine and dandy, but that's a lot of typing, and this is where closures really come in. So let's refactor this into a closure, using a closure. So how do we do that? Well, as we did before, we are going to have a constant or a variable. We'll do constant right now. I'm just going to name this a game scores sorted with closure. So I'm going to do game scores sort. And again, we do our parentheses, but inside we're going to do a closure. I'm going to automatically put the curly brackets in, so I'll just start doing the work. All right, so what do we need to do? Well, we need to have the parameters come in. So we got to let Swift know that, hey, we have some parameters and we also have a return type. So we'll do int and jint, returning a boolean. And then we use our in keyword. And then we wanted to return I greater than j. Yep. Okay. See what happens. And sure enough, it does it. Exact same thing up here. Right? Now, we can actually refactor this again. So you remember from the end of my last video, I refactored using inference so that Swift infers the type for our parameter and our return. So let's do that again here. So we're going to do let game scores sorted inferred. So we do equals game scores sort. Again, do our parentheses, curly brackets, parentheses. All right, so what do? Well, we actually let's only have this on one line. So we know that it's going to be coming in as an array of integers, so Swift can figure that out. What we just need to say is we need to give names to the numbers coming in so we can work with them. So we do I, j, in, and we do our return. So our return is I greater than j. And does it 33 times? Awesome. So when we call game scores sorted inferred, there's our sorted numbers, or sorted game scores. Does exactly the same thing as this one, as well as this one here. So it does exactly the same thing, but we've done it in one line, which is pretty cool. Now we can actually go even further than this. We can actually use shorthand parameter names. So this is the end of the section, but we can actually do this even more refactored than the other one. So again, we do game scores, sort, parentheses, curly bracket, and all we do is return $0 and then $1. And let's see what this is. So I'm going to actually assign this to a variable. Okay. Let's see what game scores sorted short looks like. All right, so it does it ascending, which is not what I wanted, so I did it in the wrong direction. And there we go. Does exactly the same thing. All right, so that is shorthand parameter names. So a little mention here. The 0 and the 1, basically what they refer to is they refer to the closure's first and second integer arguments. So basically what Swift does is it automatically provides the shorthand argument names to these inline closures, and they can be used to infer to the values of the closure's arguments. And these argument names, $0, $1, and actually that can continue on. You can do $2, $3, and etc. Right? They can continue on. So this is the first argument, this is the second, third, fourth, and so on. And so if you use these shorthand argument names within, a closure like I did, you can omit the closure's argument list from its definition, and the number and the type of the shorthand argument names will then be inferred from the expected function type. So since it's inferred, I don't need to use this in keyword at all, because the closure expression is made up entirely of its body, and the body is this here. So what it's returning. I hope that makes sense. But if you find this too confusing, I say don't use it. I would try to say if you want to just use type inference like this. I find this a lot easier to read personally. But knowing that you can go, even more stripped down than actually giving it names like I did here is nice to know. Capturing values. Closures can capture constants and variables from basically the surrounding context in which it's defined. So it can refer to and modify the values of whatever constant or variable is there from within its body, even if the original scope has that originally defined them doesn't exist anymore. Okay, so I'll show you a little example of a closure in a global context, but it's not meant to be something you should use because it's obviously not helpful. It doesn't really utilize what closures are meant to do when they deal with values. But it's to give you an idea or kind of show you that what a closure can actually do. So let's just jump in. So global meaning anything can see what is there. So if I just type out a variable and just name it a number, let's say that number equals 2, anything that sees this variable, actually everything will see this variable is what I should say. So it doesn't matter if it's above or below, it will see this variable. That's what I mean by global. I mean, you can do work on a global variable. For example, if I did var multiply by 2 and have that do some work on the number. So do times equals 2. So when I utilize this, this will actually do work. Multiply by, this closure will do work on number 2. Okay, so so if I type out this number int, we'll see that it does equal 2. Now if I call my closure, and then call a number again, you'll see that it equals 4. So it's doing work. The thing is I can call anything. I can do another closure, say add 5. Okay. And because I'm calling a number, it will change the value of a number. So if I call add 5, it will now change the value of a number. If I do a number again, as you see, it equals 9 now. So that's what I mean by a global sense. I mean, anything can have access to it. I mean, here's two closures that are doing work on a number. Now the thing is, and that's one of the things that makes closures really useful, is that they can capture values. So, and they can capture it in 2 places and be completely separate. So internal. So internal meaning not in a global context. So basically anything that's inside a closure or a function, it can track the internal information encapsulated by that variable as defined in their enclosing scope. So they basically reference the closure. And the simplest way to do this is to basically use a nested function. So I'm going to create a function here. Oops. I'm going to do that. Sorry about that. So back to where I was. So let's create a function. I'm going to create a function that will deduct by, it'll take in a number and deduct it by whatever number that you put in. So say if I put in 5, and then it will, if you say deduct by 2, it will accept 2 as what it's going to be subtracting the start by, or the number that we first set it to. This makes sense in a moment. So I'm going to call this make deduction. And so I'm going to have it bring in 2 parameters. One is our start number, and then the second one is our step. So we're going to bring one number in that will be the number that we will be subtracting from, and the step is the number that we will be, actually no, the start will be the number where we start at. So say if it's 10, and step is the number that we're subtracting 10 from. So if it's say by 2, that's what we bring in 2, or -2. All right, and then we are going to call a closure that will output an integer. Okay, so here are our parameters right here, and then our closure has this format. So no parameters, but outputs an int. All right, so I'm going to create a variable here that I can use to do work, and I'm going to set it to my start number. And now I'm going to create a function inside. So this is where the nested function part comes in. I'm going to create another function inside that's actually going to do some of the work, actually all the work. So I'm going to call this tractor. and it has to have the same format that we specified up here. So no parameters and return an integer. And now we're going to give it some functionality. So the thing I want to really point out here is that the function subtractor, I know it has this really interesting syntax right now, but the thing is that function subtractor has access to everything that's coming in to make deduction. So it has access to this variable and this, as well as the variable that we've defined inside the function. Okay, so with that being said, I can actually use everything that's coming in inside of the nested function. So I have total, and what I'm going to do is I'm going to subtract it by the step. So whatever number is brought in, that is going to be subtracted by. And then because function subtractor needs to return something, we're going to actually return total, so that we satisfy this requirement here. All right, but we're not finished yet, because we're actually missing a return with these set of parameters in return. So what are we going to do? Well, we're going to actually return the function subtractor minus the parenthesis signs. Okay, so yeah, it looks really odd. Like if you just look at function subtractor all by itself, just imagine that nothing is surrounding it. It just looks like it's unfinished, like it's missing something, but it's not, because function subtractor sees everything that make deduction function has. So it sees all its parameters, start and step. It sees the variable total because it's inside. So it sees everything, has access to everything. The thing is you can't access subtractor from outside of make deduction. And I can totally show you that. So say we're going to have a variable, and this variable is just going to be some random number. We're going to have that equal, let's say 100. All right, so if we try to do some work using subtractor, you can't. Like if I try to do some number, I'm going to try to pull in subtractor, it's not going to do anything, because you can't access it at all because it's in there, basically. But I'll try. But I don't think I can do anything. So yeah, see, and there's no member subtractor. Let's see if I can do something different, like let's do var decreasing, and let's assign that to the make deduction function that I had before. And if I do my deduction, I'm going to start from 10, and I want it to subtract by 2 every time it's called. All right. So say if I try, because decreasing is now knows that it's a closure of make deduction, maybe we can now bring in subtractor. Now I know this isn't going to work because it's not within the scope. It's not global. So yeah, see, it says not used as a property, blah blah blah. So I just wanted to show you that you can't access it. You can't access a nested function at all. But the functionality is there. You just can't do anything with it. Alright, so now that I made that point, let's move on. So I've created a variable decreasing that references the closure make deduction, or the function make deduction. So now that when I call decreasing, what it should do is it should decrease the number that we start with, 10, by 2. And that's exactly what happened. It's now 8, right? And if I do it again, it's going to subtract by 2 again. And then this time it should be 6, which is absolutely correct. Now the thing is now if I want to add this to my random number, I can just do decreasing with my parentheses. And now some random number will be subtracted by well, actually it's added, which is right. So the value of decreasing, which now would be 4, is now added to some random number, which makes it 104. Now what I can do is I can do something, I could do another variable. So I'm going to create another variable. So I'm going to just call this decreasing again, because I just can't think of a better name right now. And I'm also going to assign it to make deduction. And I'm going to start at 1, and I'm going to have it step through by 2. Now, you would think that, well, we've already used make deduction up here. Are you copying that into this one? No, I'm not. Not at all. Basically, this is another variable that's looking at exactly the same function, but because closures capture values, what happens in this variable is not going to affect anything in this variable. So they're basically completely separate, but they look at the exact same closure. So again, if I do decreasing again, and that should equal -1, because 2 minus 1 is -1. If I do it again, it's -3. And so now say if I add that to my random number, and now it should subtract. Yeah, so as you see, that's how closures kind of capture numbers. And what happens in one variable here does not happen or affect anything that happens here, because they're both defined within their enclosing scope, and they don't share a scope at all. They don't share the information that they have, but they do reference and do exactly the same functionality because they have made a reference to make deduction. Okay, so I'll show you another example just for kicks and something just a little different, because that was really extremely generic. Alright, so I used to work in a lab, so I'm going to base my next example off of that. So in the lab, I used to track cell counts. So cells that grew in flask A and another set of cells that grew in flask B, and I used to actually do counts. Now it's actually quite manual, so we won't do anything like that. But the functionality is kind of the same. Cells, they multiply, they reproduce, right, or they split, what have you. So I'm going to create a function that will account for cell division. Okay. So I'm just going to call it increase cell count. I'm actually going to call this another example. Okay, so what this function is going to do is going to take a count that you've input, and because two different colonies of cells, two different types of cells grow at different rates, we're going to be able to input the last count and then have our function actually add more cells to that count. Alright, so my first thing I want to bring in is, of course, an integer, because you can't have a partial cell. That doesn't work. You have to have full cells. So int, and what this function is going to do is going to output a closure. So no parameter, but yet it will output an int. Do our curly brackets. Okay, so I'm going to create a variable in here to help me with the calculation. So I'm going to do var total count equals 0. And now I'm going to create my nested function. So I'm going to do function, I'll do growth tracker. And now, remember above, we have to make our nested function have these sets of parameters and returns. Parameters, there are none. We're going to have one return, which is an integer. Do our curly brackets. Okay, so now what I want to do is I want to assign total count with the number coming in. So I'm going to do start count, and now I want it to return to satisfy the return that we stated here. So I want it to return total count, which is an integer. Alright, now we also have to satisfy the return for our increased cell count, which is the closure. So I'm going to do return growth tracker. Okay. Oh, minus the parentheses. Don't forget that. You've seen Swift got kind of angry about that. Alright, so I'm going to have some cell colonies. So my first colony is going to have a count of 103 or 503. Okay, and I'm going to now set my variable or my constant for these particular cells. And I'm going to say that they grow by 100. So when they do their cell division, they multiply. They usually pop out 100 new cells a day. Okay, bear with me. So I'm going to assign it to my increased cell count, and we'll put in 100. All right. So we see let grow by 100. If we hold down the Option key and roll over it, you see it is now a closure. Okay. So when we call grow by 100, what should happen here? It adds 100 to it. Let's say another day passes by, and now it should be 200. And sure enough, it is. Now, say if I have another set of colonies or another set of cells, totally different from this type of cell that I was working with prior. And this colony has a population of 123 cells, but it goes by a different growth rate. So I'm going to say this colony grows by 20 cells a day. Okay? Same thing, I'm going to use increased cell count, but I'm going to change it to 20. So if I do grow by 20, now it's 20. If I do it again, it should be 40. Okay, so you see it, both of these constants here refer to exactly the same function, or closure, I should say. But you notice their count is totally different. Like grow by 20 didn't even care that grow by 100 was, right there, right next to it. Alright, so now I'm going to go ahead and add my colonies to my totals, my running totals to my colonies. And since it's been on the third day, we're gonna add another 20. Oops. What did I do wrong? Oh, I misspelled again. Alright, so that should be, 183. I'm gonna do the same thing here. And then plus equals. And then add grow by 100. So now it's 300 cells. Should be 803. Alright. So, there we go. It's pretty awesome. Now, I know I mentioned quite a bit about closures being reference types. So, closures can be and are reference types. And what that means is that when you set a constant or variable to point to a function, it doesn't create a copy. So, it actually references that closure. So if the function is called by another variable or constant, it leads to a change in scope. So what I was saying by grow by 20 doesn't even know anything about grow by 100 because it's outside of its scope. Okay? So let me go ahead and show you an example. Another smaller example, a little bit simpler. So say if I have a variable double, and this has an int, and it outputs an int. Let me do our curly brackets, x in, and return 2 times x. Okay. Forget our curly brackets. Alright, so now if we call double 2, and it should equal 4, which is absolutely true. Okay, and now let's see, we have another variable here. Do also double. And have that equal double. Now, what do you think this would do? You would think that, well, I'm making also double, I'm assigning double, which is a closure, to this new variable, also double, that these two would have the same value now that double is 4. Let's see if that's right. So if we call also a double and input, let's say a random number of 4, what do you think it's going to be? Do you think it's going to be 16 or 8? It's going to be 8. Why is that? Well, the thing is yes, the variable also double does equal double, but if you remember, double is a closure. It's not a value. It's not a value type. So it doesn't create copies. It creates references. And because also double is outside the scope of double, it doesn't know anything that's going on with the prior double up here. It has no idea. It could care less. It only copied the functionality. Not only copied, it referenced the functionality. Okay? Alright, so I hope you liked my review of shorthand parameter names, which I covered up here, and refactoring that with my wonderful example using short. Kind of exploring how closures capture values and how closures are reference types. So in my next video, I will be touching on trailing closures, which flows really nicely into working with higher order functions such as sort, map, filter, and reduce. So stay tuned for that. Now, again, if you really like this video, please hit the like button. If you find any of my videos really helpful, definitely subscribe. Thanks.